Have you ever wondered how data scientists manage to train complex machine learning models? Or how these models learn to make accurate predictions? Well, it all boils down to two key concepts: gradient descent and some loss function. Think of a mountain landscape. Gradient descent is like a hiker trying to find a way down the mountain by always taking a path of steepest descent. The hiker doesn't know the full layout of the terrain. He only knows the slope of the ground beneath his feet. Similarly, in machine learning, gradient descent is an optimization algorithm that is used to minimize some function by iteratively moving in the direction of steepest descent, as defined by the negative of the gradient. But what does this have to do with machine learning? You see, the goal of machine learning is to find best set of weights that minimizes the difference between predicted and actual values. This difference is also known as error. Now imagine this error as multi-dimensional landscape with hills and valleys. Each point in this landscape corresponds to a different set of weights for our model. The goal is to find the point or the set of weights that is at the very bottom of the deepest valley, the point of minimum error. This is where gradient descent comes in. It helps us navigate the landscape and find the point of minimum error. But how do we measure this error? This brings to our second concept, our loss function. Most common example of a loss function is mean squared error loss function. It calculates average square difference between actual and predicted values and is formulated as follows. Over here, yi represents actual value, yi hat represents predicted values, and n represents number of data points. The gradient descent algorithm starts with some initial weight and computes the error. It then, using calculus, computes the gradient of error with respect to weights. Gradient in this case is a vector pointing in the direction of greatest increase of error function. The algorithm then updates the weight by a small step in the opposite direction of the gradient. This process is repeated iteratively till the algorithm converges to the minimum of the loss function. Imagine our initial mountain landscape as a representation of a loss function curve with the y-axis representing loss and the x-axis representing weight. When we apply the gradient descent algorithm, starting by setting an initial weight and calculating the corresponding error, the gradient points towards the direction of increase of the error function. But to minimize error function, we don't want to move in the direction of increase in the error function. Instead, we want to move in the opposite direction of increase in the error function. Therefore, we update the weight by subtracting the gradient from initial weight. But if gradient is too large, we might overshoot the minimum. The solution for that is to multiply the gradient with a small number between 0 and 1. This number is called as learning rate. The number should be large enough so that the gradient should converge to the minimum at correct pace. It means if learning rate is too large, then algorithm might overshoot the minimum. But if it is too small, then algorithm will take a long time to converge. Now, the updated equation is as follows. Finally, gradient descent is an optimization algorithm that helps us to find best set of weights that minimizes the error function. Also, the most common example of error function is mean squared error function.